Hey, boys and girls. So, on our element, compound, and mixture note assignment, there are some things I placed there for you just to help you out. And so, I put ahead a lecture. It's a fairly long lecture, but it walks you through step by step to do the notes, if you see here under the assignment instructions. And then the teacher notes that we did together in class, it's also here for you to go through, and then you have your slides and so forth. But what I want to talk about really quick is doing the last two parts of the assignment. So when you click on the assignment on page 6 and 7, here we have on page 6, after you finish the notes on this row here, slide 6, the notes end, then you scroll down to the very bottom of the slide. You're going to see some labels there. We're going to categorize these labels in this Venn diagram. And so all you're going to do is just drag and drop the answers for these, where they go, comes right back from looking at the notes earlier. And so it's giving you the chance to process what you just learned or observed. And so to get started with some of these things, I'll help you out with a little bit just to give you an idea where some things go. A diatomic element, that word dia means two. Those are elements that are it's two of one atom chemically combined together. So you can see this label over here that has H2, N2, Br2, etc. Those are types of diatomic elements. We're going to go across to look at what is an element. Now, if you go back in your notes to see what an element is, but basically an element, we can use the idea. It talks about elements. They're on the periodic table. Anything on the periodic table is classified as an element. And so back in your notes, we know that elements, there were 118 different types of elements on the periodic table. Okay. We're going to take a look at what is a compound. Compound. Now, once again, referring back to your notes or my teacher slides, either one of them, you can see here on slide 5, we have the definition of compounds. And compounds are basically, you see how they are two or more elements chemically combined. Chemically combined. The difference is mixtures earlier are they're different types of substances put together, but they are not chemically combined. And so let's take a look down here on the chart. Let's see what's our best option for compounds. So two or more elements chemically combined is the basic definition of a compound. Mixtures, as I just shared earlier, those things are not chemically combined. And we know from mixtures itself that mixtures they can be heterogeneous, they can be homogeneous, etc. Hetero being differently mixed. You can see the parts of them there. Some good examples are things like salad up top, you can see here, or cereal. And a homogeneous mixture is something that you look at it all the way throughout and you cannot see the different particles or the different parts of that. Some good examples of that are like iced tea, or looking at different types of soda, etc., a Powerade, drinks that we consume, things like that are homogeneous mixtures, and those are very good types of that. Let's go down. Now, you'll finish labeling them, you put them around. One little tip here is that all of these things, what they have in common is that they're all made of atoms. So that little tag will go right there in the center of your chart. Anytime there's overlap, you'll put those terms there, and any other overlap, you put in those little spots right there on the Venn diagram. But just do your best, figure out what you can. That's that. Let's take a look down here on our concept map. And a concept map, what it does is it links ideas together. And you have to look at the start and the finish, the ending here, to make sure you can make the proper connections. So we know matter is made of substances. And if I look at the substances we have here, it goes down and shows me water and hydrogen. Well, based on what I saw earlier in the notes, I know that hydrogen is an element. So if I think, how do I get to elements here? Because elements on the periodic table, so I know that we have substances here which contain elements, and those ones, like hydrogen, all have the exact same type of atoms. So if I look at the options over here, they have the same types of atoms. And so I can put that in there. Now, can I think of another element on the periodic table? If so, out of these options, it would go right here. Let's look at the right side. So now we have matter is composed of substances, which I know elements, one of them. Over here, we have another kind of lead part. For that, I can slide compounds over because I know water is H2O. Let's try to figure out what goes over here. So I have milk as one example and a lot of blank boxes. Well, elements and compounds are pure substances. If something's not a pure substance, well, then the best option from this chart would be something that's called a mixture. So I'll take this mixture label and put it over here. Now I can see, okay, milk is one type of mixture. Milk that we know back on our notes talks about that milk is a heterogeneous mixture. It's a heterogeneous mixture. That means it has different parts itself. Okay. So if I look back up here, I think it's on slide, let's take a look here. Slide 6, and they have the notes on mixtures, heterogeneous mixtures, etc. It talks about what milk is, colloid. The particles can be seen with a beam of light. So let's go back to the chart here. And so I know that milk is a heterogeneous mixture, and that we have colloids here. Slides on over. The other type of mixture that we know is a homogeneous mixture, the same type throughout. Okay, and so there are two types of mixtures. Well, if we take a look at homogeneous mixtures, are what we call solutions. It's particles dissolved in a liquid gives you a solution. The other type, of a heterogeneous mixture, based on the notes, give us something that we call a suspension. That's when the particles themselves are kind of just like hanging out in the liquid, and you can see them. They're moving around. One bad example is like taking like glitter and putting it in a cup of water. You can see it moving around. That's an example of suspension. And so looking at something like salad dressing, well, that's a good example of a suspension. Most of them, you can see the oil separated by whatever else is put in there. And you can see like some kind of classic examples of using balsamic vinegar, things like that. You can see those parts. So then you'll go ahead and use the rest of these terms to fill out this concept map up top. Down below, if you look at point 2 here, now you're going to separate these terms on the left side into the columns they go into. Remember, elements are anything found on the periodic table. So something like gold, for example, is an element that fits on the periodic table. Compounds, remember, are two elements chemically combined together. So, and they have a formula, typically, something like CO2. And the other one we had here, like, let's take a look here, another compound. We're going to use this example right here, which can be a little tricky. It's showing you that we have basically two atoms here connected to two other different atoms here in a chemical formula. And so that's one example of showing you how these molecules in molecular form are making up a compound. Now, another tricky part with the visual aid here, an element, we can look at something like O2. That's a diatomic element. And a good visual for that will be something like this, where it's two of the same atom chemically combined. H2, O2, Br2, I2, etc., iodine are all types of elements. Now let's look at the mixture column. Remember, mixtures are not chemically combined. And so homogeneous is the same throughout. Heterogeneous is something that's not the same. So a classic example of a heterogeneous mixture is something like trail mix. Something that is the same all the way throughout from the top to the bottom. We'll use air. Air is one classic example of a mixture that when you look at air itself, it's made of carbon dioxide, oxygen, and other small gases present, methane, sulfur dioxide sometimes if there's pollutants there. But needless to say, it's the same all the throughout And we can't tell the different parts of that. Okay, so the rest of this, based on your best intuition, I'll take this label over here, this visual. It's showing you a mixture by using those symbols, and you'll use your best guess to figure out what goes where looking at your notes. Remember, we shared earlier, like iced tea, for example, is a mixture, the same throughout, and you'll drag those labels over there. Okay? So, as always, if you have any questions, please let me know.